Okay, y'all, so we're going to start with the section 3.3 notes. We're actually going to split these notes in half. So the first 2 pages we're going to talk about today, and then part 2 will be the last 2 pages, and you'll get that video next time I see you. So this section is all about the different rules of differentiation. So these are going to be all the shortcuts that I was talking to you guys about earlier, a couple weeks ago. Shortcuts for how to find the derivative just by looking at a function. So the first shortcut is the derivative of a constant. So if I want to find the derivative of some constant, it is always equal to 0. So if I want to find f prime of x, if f of x is 7, I know that 7 is a constant, therefore the derivative is 0. Same here, dy dx, which really is the derivative of y with respect to x. If y equals 3 pi, I know 3 pi is a constant, therefore dy dx is equal to 0. That one's pretty straightforward. So every time you are having the derivative of a constant, your derivative is 0. The next rule is the derivative of a power of x. So if I want the derivative of x to the n, that's the same as putting n in front of the function and subtracting 1 from the exponent. So for example, if I want y prime and y is equal to x to the negative 5, then y prime would be equal to, I'm going to take the negative 5 and bring it down, so negative 5x, and then I'm going to subtract 1 from the exponent. So I'll have y prime is equal to negative 5x to the negative 6th power. Same situation for the following examples. So dg dx, right, the derivative of g with respect to x. If g of x is x, you have to remember that the exponent there is 1, so I'll bring down the 1, and then I'll have x with the exponent minus 1, which is just x to the 0. So 1 times x to the 0, which is just equal to 1, because x to the 0 is 1. For our next example, we want f prime if f of x is x to the 3/5. So again, f prime of x, bring down the 3/5, then we have x 3/5 minus 1, which is equal to, we still have our 3/5 out front, and then x to the negative 2/5. And then our very last example, for this one we want to find the derivative and then find the derivative at 4. So let's start with just finding the derivative. F prime of x is going to be, we'll bring down the 3, subtract 1 from the exponent. So there's f prime of x. Now if I want f prime of 4, I'm just going to substitute 4 into our derivative function. So then f prime of 4 is equal to 3 times 16, which is 48. So our next rule is if we have a constant times a function. So if u is a differentiable function of x and c is a constant, then the derivative of the constant times u is equal to the constant times the derivative of u. So for example, if we want to find f prime of x, and f of x is 3x to the 5th, 3 is our constant, so we'll take out the 3, and we're going to multiply it by f prime of x. Okay, so then we know how to find the derivative of x to the fifth, right? So the derivative of x to the fifth, we know is going to be bring down the 5, take the x, subtract 1 from the exponent. So then f prime of x is going to be 15x to the fourth. Right, and we'll just continue to do the same thing for these other examples. So if we want y prime, and y is 2 times x to the negative 3, 2 is our constant, so we'll bring out the 2. And then we want to take this part and find the derivative. So we do that again by bringing down the negative 3. We still have x, and the negative 3 minus 1 is negative 4. So then just multiply, and we have negative 6x to the negative 4th. And then our last derivative, we want to find g prime, and we have g of x is equal to negative 4x. Negative 4 is our constant, so we'll bring out the negative 4. The derivative of x, right, we bring down the 1, subtract from the exponent, so x to the 0, which is still 1. So negative 4 times 1, which is negative 4. This next piece is the sum and the difference rules. So we can add and subtract derivatives the same way that we add and subtract whole numbers and things of that nature. So if u and v are differentiable functions of x, then their sum and difference are differentiable at every point where u and v are differentiable. So the derivative of u plus v, or the derivative of u minus v, is equal to the derivative of u plus the derivative of v, or the derivative of u minus the derivative of v. So the way that we're going to do this, we're going to do a couple of steps. Right? So the first thing that we want to do is find the derivative of each section. Right? So we have dy dx, and we have that y is equal to 3x squared minus 4x plus 5. Okay, so what we're going to do is we're going to find the derivative of each section separately, and then we will add or subtract those derivatives together. So the first derivative that we want to find is the 3x squared derivative. So we want dx of 3x squared. And then from that we're going to subtract the derivative of 4x. So dx of 4x. And then from that we're going to add the derivative of 5. So dx of 5. So we have rules to help us figure out what these derivatives are, right? So for 3x squared, right, we have a constant, so we'll bring out the constant. And then the derivative of x squared, we know we'll bring down the 2, and we have x to the first, because 2 minus 1 is 1. And then we'll subtract the derivative of 4x, right? So here we have a constant of 4, which we'll bring out, and then the derivative of x will bring down the 1, and x to the 0 is 1, so the derivative of x is 1. And then this last piece, the derivative of 5. 5 is a constant, so back to our first page, the derivative of a constant is just 0. So with that, we know that we have 6x minus 4 is the derivative of y. Let me simplify. We're going to use that same process on these next examples. Okay, so now we want f prime of x if f of x is x to the fourth plus 2x cubed over 3 minus pi cubed. So again, we're going to break this down so that we find the derivative of each individual piece. So we'll find d dx of x to the fourth, and then we'll add to that d dx of, and we can rewrite 2x cubed over 3 as 2/3 times x cubed. And then we want to subtract d dx of pi cubed. So again, using our differentiation rules, we know that the derivative of x to the fourth, just bring down the 4, multiply by x cubed. And then the derivative of 2/3 times x cubed. Again, 2/3 is our constant, so we'll bring that up front. And we'll multiply that by 3x squared. And then we'll subtract the derivative of pi cubed. Pi cubed might not look like a constant, but it is a constant. And the derivative of a constant we know is 0. So we have 4x cubed plus 2x squared is the derivative of f of x. So if you're wondering how I got 2x squared, 2/3 times 3, the 3's will cancel and we're just left with the 2. Okay. And then we have our last problem. We want dy dx and y is equal to 6x to the 1/2 minus 4x to the 3/2 plus 2x to the negative 1/2. So again, separating it into separate parts so that we can find the derivatives of those different sections. So d dx of 6x to the 1/2 minus d dx of 4x to the 3/2 plus d dx of 2x to the negative 1/2. Alright, so for the first section we have a constant that we're going to pull out, and then x to the 1/2 will bring us 1/2 x to the negative 1/2. Then we'll subtract the derivative of 4x to the 3/2, so we'll pull out the 4. And then the derivative of x to the 3/2, we know we'll have 3/2, then x to the 1/2. And then we'll add the derivative of 2x to the negative 1/2. So we have a constant 2. And then we have negative 1/2 x to the negative 3/2. And when we simplify everything, we'll have 3x to the negative 1/2 minus 6x to the 1/2 minus x to the negative 3/2. And that is that for today. If you have any questions, please make sure you drop them down and bring them to class tomorrow. We will go over a few examples together just to make sure everybody's on the same page before you start working on the problem set.